Hello, my name is Yuri. I have a master's degree from Aarhus University in psychology. So I wanted to make a video about a chapter in this book, the Handbook of Evolutionary Psychology. It's written in 2005, and David M. Boss is the editor, so he combined different chapters. In 2005. All dedicated to Charles Darwin. So it's a handbook of evolutionary psychology, so it presents evolutionary psychology, and it has chapters about all the different scientific areas. So all the great minds in evolutionary psychology have written their own chapter for this book about mating, survival, group living, parenting and kinship and stuff like that. The chapter I'm most interested in is this Conceptual Foundations of Evolutionary Psychology. It starts on page 5 and then ends here on 67. It's about 60 pages long. And I like it because it's a great introduction to evolutionary psychology and the basic premises. And as you know, handbooks are always like this. They always present the science and always have a lot of different chapters. I've actually reviewed all the different chapters individually from the new edition of this handbook. So there's a new edition, but I think this chapter is by far the best chapter in either editions of the book. And the new chapter in the new edition it's kind of bad. I don't like it at all, actually. So, but I really like this chapter. Let's look at it. Here it is, Foundations of Evolutionary Psychology. Oh no, wait, here, Conceptual Foundations of Evolutionary Psychology. That's the chapter. It's written by John Tooby and Tooby Cosmides, and they are some of the people who started the field of evolutionary psychology. They kind of created a foundation for it so it could become a proper science. That's also something they write a bit about in this book. Okay, I have marked the most important thing with yellow text. So this text that I marked with yellow is the text that I think is essential to understand and read to understand this chapter. Everything is really important to read and understand, but the yellow text is essential for getting the foundation for evolutionary psychology. So I will need some time to read it to myself, all this yellow text on each page, and then I will explain to you what it means, and you can also read it while I read it too. I won't read it to you because my accent is too heavy. Okay, they are writing about evolutionary psychology as a new foundation for psychology as a whole, and it's a science that has had a long time coming because in the Origin of Species, Darwin already mentioned some of these psychological mechanisms that could have been involved. He also wrote some other books about all these different mechanisms, but he didn't create the science of evolutionary psychology. He just kind of started up the whole thing. But now in the 80s and 90s, the science was created. So it was, before that, the psychology was all over the place. So we had different kind of areas that we studied, and evolutionary psychology is an umbrella for all of psychology. So it's a foundation for psychology. Now we'll explain why that is later. So finally we have this foundation. We never had any foundation for psychology before. We never had this umbrella that kind of included all of psychology. So this is the first time we have it, and so far no one has been able to disprove it, and so far it has been a great model for predicting our life and predicting human behavior. So the science we have done on this area have just supported this theory from day one. That's a good thing. Yeah, these models should include the neural, the mental, genetic basis of these mechanisms and encompass the design of other species as well. So it's about the brain, the whole brain, and other species. Yeah, and they also say that it will be this foundation for social sciences because, for example, racism. What is racism? Again, evolutionary psychology creates the foundation for racism. How we create alliances, how we create in groups, stuff like that, right? And group dynamics. That's evolutionary psychology because it's in our brain, in some mechanisms in our brain. So when you talk about social science, you have to have a foundation. And before that, we had this foundation, standard social science model. They had a great chapter in the 1992 book they wrote. That's the foundation for evolutionary psychology. That's where we really had the first great foundation for this science. And then they explained the social science model that also actually Pinker also explained in his book Blank Slate. And it's an idea that all psychology is just based in a kind of vacuum. So all models are in a vacuum by themselves because the brain is just a sponge or just growing by itself. There's no clear instructions in the brain, so everything comes spontaneously or just comes from society. So it comes from outside into the brain. Okay, so there's no explanation of it. Yeah, they say organization flows inwards to the mind, but does not flow outward. So it's not studying the brain and thinking, hey, how could this behavior have been created via evolution? But it's more like studying men or studying women or studying black people or studying, groups or studying religion and then saying, okay, or rich people and saying, okay, they have influenced our behavior this and this way. Men like women because their behavior has been influenced this and this way, stuff like that. So from outside in. And the blank slate is a great introduction to this concept and to the whole of this theory. Yes, and before evolutionary psychology, we always had scientists that said that there are some structures in the brain, but before that, the standard social science model was that we don't have a clear conception of the brain. We don't have a clear conception of human beings. It kind of soul. It's a blank slate, and stuff is just written on this blank slate. Oh, they say here the social science model will have to be dismantled. So it has to be broken apart because we have new concepts, we have new ideas, and new science. Oh yeah, it has been strongly moralized too. So they say that there is also some moral concepts that are kind of um, motivating some people to use this social science model. So that's what we had, and that's also what we still have. There's a lot of people who kind of try to look at psychology in a holistic way, in a spiritual way, in a kind of like a Buddhistic or Hinduistic way, spirits and ideas and stuff like that. That you as soul, so it's seen this way, where everything is possible and human beings are special and are unicorns in the animal kingdom. This is interesting because here they explain everything that evolutionary psychology can explain. theories of, oh yeah, and the theories that can be created in evolutionary psychology, theories of how natural selections act on altruism, kinship, cooperation, mating, foraging, reproduction, parenting, risk-taking, aggression, senescence, host-parasite interactions, intergenomic conflicts, life history, communication, and many other dimensions of life. And that's some of these dimensions that we study in evolutionary psychology. So yeah, that's just a point about all these concepts in our mind. For example, it's like our vision, right? We didn't just, an organism just didn't have eyes and complete vision as we have today. It started slowly, right? You can maybe perceive some light, and then a bit more light. Maybe you could perceive a few colors, maybe a few more colors, and then it's kind of developed from there. So yeah, that's how our brain too developed, because for example, our perception of hunger, our perception of groups, our perception of mating, our perception of children, again, these perceptions kind of evolved through millions of years. And also they say here that they evolved for different kind of livings, different kind of natural environments. I think they kind of explain it on another page too, but it's environment of evolutionary adaptiveness. So it's all these mechanisms we have in our brain are evolved for old environments that we kind of don't have anymore. Now we're living in a modern world, so yeah, we need to look at other species to see how they use their mental mechanisms, and look at our forefathers, hunter-gatherers and stuff like that, to kind of understand how some of these mechanisms could have been evolved in that kind of environment, because evolution is very, very slow, so we have not yet fully adapted to a modern environment. But we still use our old mechanisms. There's nothing new in our brain at all. Oh, this is very interesting. Psychology and evolutionary biology can no longer be defensively divorced. So there's no divide anymore. We cannot say that there's some spirit or some soul or some blank slate in a brain, something that's influenced only from the outside. We need to look at biology too today, and this is actually what the evolutionary psychology does. That's the biological foundation for psychology. So the mental world is no longer a mysterious realm. Or computational adaptations. Unlike some of these things I've marked are because of the great words and examples they use. For example, computational adaptations. That's a great way to explain how we adapted to group living and siblings and stuff like that, right? Computational, it's kind of a computer that evolved gradually, or maybe you can look at it like software. So we had some software, but it evolved very, very gradually. So it was the most fit survived and the less fit died off. So it's kind of evolved this way. Also, again, they say that, okay, now we cannot use religion and theology to explain our physical being and our mental being. We have to use modern science. So with these kind of genetic studies, some biological studies, some brain scanning, stuff like that, all stuff that again show that this foundation we have of evolutionary psychology and the theories we can deduce from that are true. Of course, some are not true, but still all this foundation, all this scientific foundation we have are also used to create new theories in evolutionary psychology. Also interesting, actually, it departs from fitness theologists. So I hope I understand this word correctly. But it departs from this economic thinking, or this kind of primitive thinking of evolution, that we're just a fitness machine. We just try to improve our own fitness and use all means to improve our own fitness. That's actually not correct, because that's not what evolutionary psychology is, and that's also not what evolution is. Evolution is that it's a machine. We are a machine, or rabbits are a machine, or lions are a machine, that are created to solve some problems, right? They're not created to just maximize fitness, because they're created to solve problems that will then maximize fitness, okay? So when something goes wrong, and they will do something wrongly, or they will misperceive something, that's not maximizing fitness, right? For example, our biases. If I see something, a bush shake, I will run away. Maybe I will run away from the bush because I think there's a lion inside this bush. That's of course a good bias to have. So you fall on the right side. You perceive that there's more danger than there actually is, so that you're more careful this way, right? Oh, I think they're talking about this here. Yeah, but it's better to run away from the bush an extra time than to run away from it one less time and be eaten by the lion. So these biases we have sometimes make us fall on the right side, right? And they sometimes make us see the world in a certain way, and sometimes we make extra mistakes this way. We're extra careful, so we run away from all bushes. But it's better than not running away from from any of them, or even running away from like half of them. It's better just to run away from all of them, right? That's the safe way to live. So yeah, these mental mechanisms and models and physical beings are just created to survive and reproduce. But sometimes we get it wrong, or they get it wrong. The mental models get it wrong because they're not infallible. Like to say here, men will pay non-protective sex with. They will pay for non-protective sex with prostitutes. So why is that? Because that doesn't make sense. They don't reproduce here, or they get paid to contribute to sperm banks, right? So if you're just trying to reproduce, why wouldn't you pay the sperm banks? So that's again because these mechanisms you have in your brain are not created to maximize fitness in all possible scenarios. And here, in rich countries, we get fewer children, not more children. Again, why do millionaires not just get 100 children? Okay, natural selection does not operate on behavior per se. It operates on systemically caused relationship between information and behavior. Running a behavior is neither good nor bad. Running away from a lion can promote survival and reproduction. Running away towards a lion will curtail both. To be adaptive, behavioral regulations need to be functionally contingent on information. For example, flee when you see a stalking lion. Yeah, they're just evolutionary concepts about survival of the fittest, right? So if you're a bit more fit to the environment, if you're better reproducing, better surviving, then the genes you have will better reproduce, better survive. Okay, although organisms sometimes appear to be pursuing fitness on behalf of their genes, in reality they are executing the evolved circuit logic built into their neural programs, whether this corresponds to recurrent fitness maximizing or not. Organisms are adaptation executors, not fitness pursuers. So again, they say that these brain modules, brain mechanisms, they have evolved via millions of years to solve problems a certain way. And they just solve these problems a certain way because that was the best way to solve the problem, right? That was the fitness optimizing way to solve the problem. But we don't even need to understand what fitness is. These mechanisms are just doing stuff, right? So not all animals need to understand, hey, I'm a living being. If I do this, I die, or I can survive better like this or this, or maybe I can think up a new scenario for stuff I want to do. We're just kind of doing what we are programmed to do. And these programs, at least the programs would really study in evolutionary psychology, because we have studies about all animals, but evolutionary psychology is mostly focused on the stuff in our brain that makes us different from other animals, right? And we look at hunter-gatherers ancestors to really see where these mechanisms evolved that make us different from chimpanzees or bonobos or lions or cats. And these are problems such as finding a mate, cooperation with others, hunting, gathering, protecting children, navigation, avoiding predators, avoiding exploitation, and so on. So we look at all these stuff that have been useful in hunter-gatherer societies. I think I'll write a bit more about it later. Yes, they are also called instincts. You can call them module in a brain, a module. You can call them instincts, you can call them mechanisms, whatever. It doesn't really matter. At least it doesn't to me. But yeah, instincts is a great way to say it all, because it can be reasoning instincts, decision instincts, motivational instincts, learning instincts. They are instincts. It's an instinct to learn. It's not just a, hey, we can randomly learn because we have a soul. No, it's an instinct. We have instincts, right? They evolved via millions of years, and then we can learn because we do have these models to learn. We do have this program. If we didn't have this program, then we could not be able to learn. Our motivational instincts. If we didn't have these instincts, we would not have any motivation. It's not just something that comes about by itself. Or decision. When we make a decision, we're gonna have how many instincts? Maybe there's 1,000 decision instincts in our brain. Maybe even more. Maybe all in all we have like 100,000 instincts. So a lot of instincts, a lot of modules, a lot of software. You can look at it like software, right? It's software evolved to make us do certain things. Oh, I love this example. As you say, a 4-year-old, if a 4-year-old sees another child, I think it's like this. If a 4-year-old sees another child look at a candy, he knows that the other child wants the candy. But some autist people will not be able to perceive it, even as they are adult people. So they will not understand that if another person is looking at the candy, he wants the candy, right? So why are they not able to perceive it? Because a lot of this stuff can be found in even very intelligent autists, right? They will have difficulties understanding some of these social interactions. So why is that? Because sometimes they are super clever. They study mathematics, they study physics at the university, maybe even psychology. And they are like super intelligent in that field, but they have problems understanding how people look at stuff or how they talk to them, stuff like that. So why is that? That's because exactly they are missing some instincts in their brain, like say some cognitive mechanisms, right? So it's not just enough to be intelligent, because you cannot just think your way out of everything and into everything, because this human interaction is also instinctual. So if you don't have an instincts for how people see things, or how they talk to you, or how instincts for to perceive their brain and perceive other human beings, then okay, that will be a loss for you, and that would be a huge disadvantage. So I'm not saying that autists are missing a certain instinct. I'm just saying this is a great example, because you can lack an instinct if there's a developmental problem in your brain, something went wrong in your brain, and you will not be able to do that, like one thing. Maybe you have a hard time remembering faces. Why is that? Because it's an instinct. It's not just enough to be super intellectual to remember faces very well, or names. Maybe you don't remember names that well. Maybe you have a hard time remembering colors. Oh, this is super interesting. As a species, we have been blind to the existence of these instincts, not because we lack them, but precisely because they work so well, because they process information so effortlessly and automatically. Their operation disappears unnoticed into the background. So yeah, again, it's like when you see a face, there's like 100 instincts popping up, right? Or maybe only one, I don't know. But at least you see a face, and you need to, we already have studied babies. We know that they understand faces right from the get-go nearly. So we know they have some mechanisms in the brain that make them recognize mouth and eyes and how they are related to each other, stuff like that, right? And we also know other animals can do that too, for example, chimpanzees. So that's again an instinct. And it's not something, like, oh man, now this instinct is running, now this software is running, or that instinct is running. For example, when we see people walk, that's again an instinct, because to perceive motion, to perceive how people walk, how animals move about, how birds fly, it's all separate instincts, right? So it's all something we have to have in a brain to understand. But it's not like we see someone walk and we think, hey, that's a good thing I have that instinct. No, we just think, hey, we just see them walk and we just understand it because it's easy to understand. That's not, that would not be how we would perceive it if we are not evolved this way. So if we are evolved in a world where no one walked about or no one had faces, then we would not have instincts to recognize faces. We'll just have other instincts that we maybe could use to differentiate faces a little bit, right? But not as well as human beings today do. We do not realize that normal behavior needs to be explained at all. It's like the color perception. That's the old example. Like if let's say an organism's evolved in the dark, or evolved in an area where there are no green colors, yeah, well, then they probably cannot see green color, right? Or they probably cannot see color at all if they have evolved in darkness. That's the same thing. We always need some mechanisms that evolve to solve this problem. Again, for example, a mutation that causes family members to find other family members sexually repugnant. So this mutation would actually mean that the people with that kind of mutation would have children with fewer genetic diseases, and therefore their children would be more likely to mature and reproduce than the children who do not have these kind of instincts in the brain. So it's incest avoidance. Oh, we're already very far. Wow. Only mentioning it here. Okay, environment of evolutionary adaptiveness. Again, it could refer to hunter-gatherers, right? As I said, the environment where mechanisms for social living evolved. But that's the human being social living, because before that we were chimpanzee-like monkeys, and before that we were kind of, we had 4 legs. I mean, so reptiles, yeah. Before that we were reptiles, and we were also fish at one point. And at all these environments, some mental mechanisms evolved. So you cannot just look at hunter-gatherers alone. You need to look at all these kind of different kind of environments that could have evolved our physical being and mental being. But hunter-gatherers are by far the most interesting thing for psychologists, because we look mostly at human beings, and we really like to look at religion and social life and stuff like that. So yeah, consciousness. So we like to look at this, or language too, these kind of advanced, as we call them, mechanisms. And again, evolutionary psychology would need to be the foundation for consciousness and religion and social life and all these things. And again, all these theories that we propose from this foundation, they still need to be testable. So it's not, you cannot just make stuff up. When you make stuff up, that's a hypothesis, right? Let's say I think men are on average taller than women. Okay, I can say that, right? That's a hypothesis I can get. I can say I have, and then we can test it and see if it's true or not. So let's say we test 100,000 men and 100,000 women in a certain country, and then compare heights. So if men are on average taller than women, then I have a study that is supporting my claim. And when we have 100 of these kind of studies, then we kind of think that, okay, this claim is probably true, because we have studied it in all different kind of cultures. So we assume this claim is true. And that's how I see it. I don't just say men are taller than women. I'd say it because I think science supports this claim. But if you have studies that disprove this claim, that I will look at them. Oh, this is such a great text. I don't know if I should read it because I have an accent, but yeah, we have a sexual division of labor. There were fungi, bacteria. There were group living. We ate all kind of food, both meat and vegetables. We were hunting, we were gathering, and mostly men were hunting, and both sexes were gathering, but women gathered more than men. We had long periods of parental investment, male-female mateships, lactation, we are long-lived, stuff like this, all these kind of stuff. That's something we know about hunter-gatherers in the past. We also studied a few hunter-gatherer groups. You will rarely than if ever see more than 1,000 people. And our kin-based bands were often 20 to 100 individuals. So small groups, that's something we know, right, from these hunter-gatherers. So it's not like we don't know anything about hunter-gatherers of 10,000 years ago. No, we have studied hunter-gatherers 60 years ago, and we have also studied human beings today. So we kind of can predict a lot of this stuff. And all of this stuff is used to create good hypotheses in evolutionary psychology. which then we need to test. The hypothesis by itself is completely useless. Not completely, you can test it, but that's it, right? I can say stuff like men are taller than women, but it's completely useless unless we test it again and again and again and again. It's actually very interesting because we also have different kind of perception of sharing. For example, as they say here, meat and honey was shared widely with the band, but vegetable foods, that were plenty. We had vegetables everywhere, right? You can just go out and then find it. That was only shared with the nuclear families because they can get their own vegetables, while we kind of needed to share the meat because it's not every day we had new meat. So we have these kind of different instincts for different kind of sharing that we also need to understand. Yes, again, like neural programs for acquiring spoken language. Let me see. Yeah, exactly. That's how I remember it. Because you have these neural programs that allow you to acquire language, right? So you have these programs that make you able to learn to talk, learn to understand words, learn to understand other people, and they can also consist of like a lot of different instincts together because you still need to talk to other people. So a lot of instincts are probably combined. So you can learn to talk, of course, but when you learn to read and write, that's not an instinct by itself. Okay, there's no instinct to read or an instinct to write because you're just using a lot of different instincts you already have in your brain to do this kind of stuff. It's like learning to play a piano, right? There's no instinct to play a piano, but you still can do it because you have instincts for other kind of stuff. And as you say, for example, one instinct can be very, very good for solving one kind of problem, but then terrible at solving another kind of problem. So you need an instinct for all the different small problems that you can have in life, not just one instinct to solve everything, like a bad sonar, for example, or a bad sonar is actually a good example. It's poorly suited for other kind of problems, right? But it's well suited to find prey. Yeah, they're kind of saying all the stuff I already said. That yeah, use yeah, but you should probably read it yourself because so we predict a certain instinct in a human being because we think this instinct could be universal. We think it can be found in all cultural settings, and we think it could have been found 10,000 years ago and 100 years ago, 100,000 years ago. So we kind of then we test it by using methods from cognitive psychology, social psychology, developmental psychology, cognitive neuroscience, neuropsychology, experimental economics, cross-cultural studies, and all these different methods. We have two to see if our prediction is true or not. We also try to dispute it, and we also need to study this instinct in as many cultural groups as we can, as many countries as we can. So, and thereafter we slowly start to create a theory, and then we slowly start to share this theory or write it in textbooks. But you kind of need like 100 different articles or scientific studies to create a good foundation for that one hypothesis. Well, that's a lot of text, right? No, they say, hey, for example, to avoid mating with a kin, you need to first understand a kin, and then you need an instinct to find sex repugnant with the kin. Also, they say, but how do you understand your relatedness, genetic relatedness? But that's, again, we look at essential hunter-gatherers and how they lived. For example, if you can see that kids grew up with the mother, so we know that there could have been some mechanisms there that made them understand that this was their mother and these guys were their siblings. So that's how we look at the environment of evolutionary adaptiveness. And as they say here, this has of course been confirmed since then, that we actually do have these kind of instincts. We do think this way, we do act this way. And as they say here, these kind of instincts were often uninvestigated by traditional psychologists or cognitive scientists because they kind of didn't predict them. They didn't think they were there. They just studied whatever came up. But now we can predict behavior. So now that we can say that, okay, this behavior actually makes sense in this and this way. So you should probably start studying it by this and this way. And we can find it if we do these and these kind of studies. And then we can try to prove it and disprove it. Yeah. And it's not a general purpose learning mechanism because there's no such thing. It's completely bollocks. No general purpose learning mechanism. You can only use the brain that has developed in millions and millions of years. Another interesting thing, I can maybe read it. I don't think I need to read all this yellow text because when I read it, it's kind of okay. I already remember it and I already knew it from other books and stuff like that. But this is about evolutionary psychology not being on a pendulum from nature nurture. So it's not like we are swinging over to the nature side of the pendulum. We are pendulum. We are always nature nurture. It's always a mix. All psychology is always a mix, right? So all our mental states, even instincts, cannot be just understood by biological aspects of them. So yeah, it's not evolutionary psychology is not a fight between nature and nurture because it's not even a part in this fight. It's apart from it. It says that it's all combined, it's all one, it's all holistic. There'll be some other interesting stuff. I think I will take it up when they write about it. Oh, even if a program that causes a particular kind of learning was itself learned, there had to be a prior program that causes the learning to occur and so on. For example, when you learn a language, you can learn to read and write. So innate and is not opposite of learned. Yeah, they can just say it's one thing. And evolved is not opposite of learned, right? Because you always have some instincts that are basis for this learning. So you always have this basis, but you always need environment, because without environment it doesn't make sense either. So it's always a mishmash. Oh, there does not appear to be a single program that causes learning in all domains. For example, kin detection, right? We cannot use these kin detection instincts for food aversion. And then food aversion instincts, for example, if you avoid spoiled food, you cannot use these kind of instincts for snake phobias. And then snake phobia instincts, you cannot use them for grammar acquisition. They're all separate instincts for learning. It's caused by multiple programs. Evolved programs, instincts are not the opposite of learning. They are engines to which learning takes place. For example, there are instincts for songbirds. That's a great example, because songbirds are not born with songs. They actually learn songs. But it's not like they are just one day waking up and deciding to learn bird songs, because it's still instinctual behavior to do it. It's like human beings and language. It's not like we one day wake up and start to learn language. We do it from the get-go. We are mechanisms evolved to learn language. And again, just because we don't have it from birth doesn't mean it's not learned. For example, we don't have teeth, breasts, some hair. We don't have that from birth, right? We didn't have it from the get-go, but it still developed over time. And that's the same with these instinctual learning mechanisms. For all language, for example, we don't have it from the get-go. It doesn't mean that language is not instinctual. It just means that these instincts are acting on the environment around them and then learning a language. So yeah, that's what they say. Infants need the suckling reflex but not sexual desires. Adolescents need sexual desires but not suckling reflexes. So again, these instincts can also act on different kind of ages, right? We need the sexual desire later, but doesn't mean it's learned. And suckling reflex is an instinct. It doesn't mean that it's, yeah, I don't know. Yeah. Presence at birth is only a function for what is needed at birth, not an indicator of whether something is or is not a part of an evolved architecture. So again, it's like you you have a computer, and then startups in BIOS, and then it goes over to Windows, right? But BIOS is still needed, and Windows is needed. Both of these programs are needed. But then one program could maybe just turn itself off, and then the other program is running by itself. And infants who cannot crawl do not need to fear heights, but infants who crawl need to fear heights. Okay, it all makes sense this way. It all makes sense in this kind of evolutionary thinking, right? If you think about it, and then you test it. Of course, you cannot just write a book about fear of heights and then just randomly write stuff. You need still to do some studies. So it's coded in our genes, and our genes, yeah, it's a code in our brain, code in the genes, instincts, and then these instincts interact with the environment, and then these computational mechanisms evolve via this interaction. But it's still something that starts up in a bird. So the power on button is from a bird, and it has powered up a full system, full computer that's slowly starting up. Yeah, some neural programs are designed to take a lot of information from nature and a group. So for example, let's say you're born in a group where there's not that much food, then maybe some of these mechanisms in your brain will be developed a certain way. And some mechanisms are just developed pretty much the same in all kind of groups. For example, let's say you have instincts for vision or instincts for picking up objects, stuff like that. That could be useful in all kind of environments. But for some environments, some group livings, you probably need some more adaptability. And also the variation in between human beings, for example, in oceans. Ocean, that's a big five, that's the personality traits, right? We have these big five category of personality traits. We also have intelligence that can vary between individuals, and they explain it like a stomach. All stomachs are pretty much the same, but they can have different sizes. It's the same with human beings, right? We have pretty much the same mechanisms, but we can have different levels of intelligence or different personalities. So just variability this way. But the same concepts, the same mechanisms are in all human beings. It's universal. That's what the evolutionary psychology by itself tries to study. But still, all evolutionary science is part of evolutionary psychology. Oh yeah, they say that variability in human beings are less interesting for evolutionary psychologists. Yeah, that's true. Oh, they also they have a lot of theory and foundation for how human beings are the same, how we're all equal and stuff like that. So yeah, I also study other areas of psychology. But mostly evolutionary psychology try to look at stuff that's universal. This is an interesting chapter from, or just text, a bit of text from this guy. Most theorizing assumes that there's a general purpose learning process in the brain, a process adapted only to solving the problem of learning. There's no attempt to formalize what the problem of learning is, and thereby determine whether it can in fact be conceived as a single uniform problem. From a biological perspective, this assumption is equivalent to assuming that there's a general purpose sensory organ which solves the problem of sensing. Again, we have different kind of senses. Even our vision, we have like different kind of instincts in our vision by itself. So we can see, you can see color, you can see, you can also perceive movements. That's an instinct for that. You can also see horizontal or vertical movement, horizontal or vertical movement. I think there's two different separate instincts actually. So you can lack one and not lack the other. Also 3D perception, you need a lot of instincts for that, right? Different instincts. It's not enough to just say, hey, we have a vision, because there's a general purpose vision module in our brain that kind of develops over time. No, it has developed over time, but it has been a very long time, million of years. The same passage could be written about reasoning, memory, or attention. Again, a memory. How is a memory constructed? It's very complicated. It's not just a sponge that collects memories. There's one memory, there's one memory, there's one memory. It's super complicated. There's a lot of different structures and stuff. That's why it's a science. One system preferentially attends to the human faces. Then there's a system to see what location eyes are gazing, and we can monitor animals for changes in their state or location. And then of course these kind of mental systems can be used to detect other kind of movements. Also in cars, for example. That's what they write about here. We didn't evolve to perceive the movement of cars, right? Well, we can still do it. How can we perceive how cars move, and how can we avoid getting hit by them? That's exactly because we have perceived animals moving around in millions and millions of years. So we have these instincts to perceive movements this way, and that instinct can then be used to perceive cars driving on a highway. Again, the same with language, and then writing and reading. You have one instinct, but it can be used on other stuff. Also here they write that 3- and 4-year-olds in all kind of societies, in urban Berlin or in like in jungle villages, they all have a perception for predators or prey interactions. So they all understand these kind of interactions. That makes me think about children books and children toys. They have a lot of animals they play with, and they like to learn about animals and stuff like that. That's of course not just because we have arbitrarily created these animal toys. It's because they want to play with animals, they want to play with stuff like that, they want to learn about it, and they have instinctual learning capabilities for learning about giraffes and elephants and lions and stuff like that. Oh yeah, and then these memory systems can be totally different categories. You can have a category for animal, or different kind of artifacts. You can have different that's another science, but you can have different kind of memories for different stuff. So for example, you can forget all the animals you know. This is very interesting because they're saying, let me just read about it. They're saying that we should not have chapters on attention, memory, learning, reasoning, and stuff like that. Because again, where do we have memory? You have memory in different kind of ways of living, right? You have memory with family members, you have memory with friends, you have memory for food, you have memory for predators, you have memory for prey, you have memory for how you go to sleep, or I don't know. You have memory for different kind of stuff, right? So it's not enough to just say, hey, you have a memory or you have an attention. Okay, but then you're gonna have an attention for predators. You're sitting, being attentive to predators, or you can have attention to prey. That's a different kind of attention. Or you can meet a fancy maid that you find attractive. That's again a different kind of attention. So it doesn't make sense to divide psychology textbooks into these kind of categories, right? What is attention? It's for them, for evolutionary psychologists, it's often very good to divide textbooks in other kind of chapters for where we live. So for example, we have kin, that means siblings, parents, stuff like that, and then we can have certain kind of learnings for that, because we also have instincts for learning something from kin, right? So that's another kind of divide in chapters. At some point, all psychology will be evolutionary psychology, simply because it will make no sense to wall off the study of humans to the rest of the natural world. Again, all other animals, when we study them, we have other kind of chapter divisions. We don't have a chapter just on memory or perception or attention, stuff like that. We have divided chapters by foraging, kinship, predator stuff, and other kind of stuff. It's more natural for this kind of science that proposes that human beings do not have a soul that is unique in the animal kingdom. We're just an animal. More advanced animal, but still just an animal. What happens? Textbooks in psychology will no longer be organized according to folk psychological categories such as attention, memory, reasoning, learning. The chapter headings will be more like those found in textbooks in evolutionary biology. Wow, what the hell? Behavioral ecology, which are organized according to adaptive problems animal must solve to survive and reproduce. Foraging, hunting, gathering, kinship, predator defense, resource, competition, cooperation, aggression, parental care, dominance, and status, inbreeding, avoidance, courtship, mateship, maintenance, trade-off between mating efforts and parenting efforts, mating system, sexual conflict, paternity uncertainty, sexual jealousy, signaling and communication, navigation, habitat selection, and so on. Again, for example, when you habitat select, you need these kind of memories, you need this kind of attention, you need this kind of reasoning, you need this kind of learning to be able to habitat select in the environment. And you still have these instincts, these kind of memories and learning. You can use them in a lot of ways in the modern society, but doesn't just make sense to say, hey, you have a memory. Because yeah, you have a memory, but it's very, very complicated. You have different kind of uses for this kind of memory in these different kind of settings. And in some settings, your memory can be very, very well functioning. In some settings, it can be it can lack some instincts for being able to learn that effectively. So that's what this divide is more clear, and it makes more sense. Yeah, we're nearly done. We only have like 13 pages left. No, 16 pages left. It's very interesting. For example, if you need to understand why you feel a bit sick, yeah, I think I will just skip this. But yeah, you cannot just start from an end and then say, then go logically about it. You need to kind of feel in yourself, okay, which kind of feelings do I have, and then use the memory that has been adapted for this kind of problem solving. And you can also be different kind of sick. For example, you can have eaten something, that's one kind of sick, so you need the memories for food and what have you eaten, what do you remember about this food, do you regularly eat this food? Or you can maybe be another kind of sick, maybe an arrow had hit you. Okay, what kind of, now you feel sick in another kind of way, you need other kind of memories. You cannot just logically solve the problem by going one step at a time. You need to access one part of your brain. I can say it like this: one kind of your memory, one kind of module for problem solving. There's no such thing as the learning process, rather there are many different learning processes. Without domain specialization learning mechanisms, we would learn nothing at all. Also very interesting that we perceive stuff, but if there's something lacking, some evidence, some clues lacking, we just fill out these clues and kind of infer stuff from that. So again, it shows that our brain is not a super objective computer, but it's a computer that assumes stuff and kind of solves problems in the most optimal way, but never a perfect way, because we don't have perfect information. That's for one. And the other thing is that even if we had perfect information, our brain is not developed to perceive all information we have in the world at once and then come up with the best possible solution. We're optimized machines, but not perfect. So we perceive as much possible information as we need to solve the problem. Yeah. Yeah, even for food domains, we have salt, sweet, bitter, sour, savory, fat, affordances, smell. Oh, also these are systems in our brain for these kind of stuff. How we perceive them, how we taste them, how we avoid them, how we try to get more of them or get less of them. And they say, yeah, we have snake-like entities in our brain, right? Again, I'm not saying we have mechanisms in our brain that for all different snakes that our forefathers have ever seen. We just have like snake-like entities in our brain, and they still need some influence from environment to kind of be well developed. But we still can look at a stick and think, hey, oh, that's a snake. But maybe you can also grow up with snakes and then kind of be more accepting of them. But there are still these modules that are makes it very easy for us to learn to fear snakes. Yeah, individual experience. And these kind of course, these kind of instincts for fear of different kind of stuff is not just for random stuff. So it's not for rabbits or flowers. Oh yeah, we have a problem here. It's difficult to sleep when your heart and mind is racing with fear. So disastrous consequences would ensue if your sleep programs are activated when you need to fear. And what do they call this? They call this emotions. Emotions are these what do they call them? They call them like subordinate programs. So it's like programs that activate a certain kind of program. It's like when you actually, I would explain it like when you have a car, if you have a button for racing mode, you push the button and the car goes into racing mode, so it's better for racing. If it's a computer gaming PC, you maybe have some gaming software, you turn it on and then it makes your computer into a gaming PC, because maybe it shuts down some software running in the background, so it's better for gaming. That's pretty much how emotions work. They activate certain kind of instincts, certain kind of memories, certain kind of modules that you need to solve this kind of problem you see in front of you. And you can have different kind of memory emotions at one time, but yeah, that will activate different kind of programs. But yeah, as they say here, you kind of need the fear emotion to override your sleep emotion as well as possible to survive. So that's how they explain emotions. Why we have emotions. Emotions are there to create a kind of web to like sling around the parts of the brain we mostly need to solve the problem we see in front of us. Oh yeah, because we have these kind of subordinate programs, some people think we have free will. And that's of course, free will is an illusion. And it's just a computer that have a subordinate hierarchy of programs. A program that controls another program. For example, Windows can control these kind of programs, or maybe you have a game and then you have different games you can open in that game. For example, a game for playing board games, you can open small board games in that game, stuff like that. So you can have a hierarchy of instinctual programs in a brain, or mechanisms in your brain. You don't need to all be the same level. For example, emotions are, it's not like they're better or worse than other instincts, but they're still these subordinate programs. Information gathering programs are redirected. Where's my baby? Where are the others who can protect me? Is there somewhere I can go where I can see and hear what is going on better? So again, you have these emotions or these modules that are activated, and then these different kind of things are activated thereafter. That's what I was talking about with memory and what was the other stuff they mentioned, but perception, stuff like that, right? I can't remember it, but yeah, they are all activated in a certain way, so you can use them to solve this problem at hand. Oh yeah, and hallway closet or branches of a tree can become suddenly you perceive them as categories of safe or hiding place. So usually maybe if you're on a playing mode, so you have these happy-go-lucky emotions or happiness, then you see trees as something good, some like toys, you want to play with them, play around them. But then when you fear, you see them as you perceive them as in the categories of safe and hiding place. Okay, well, that's why you need these kind of emotions to tell your brain to, hey, now you need to access this kind of categorization of the world. And that's why also you can have depression, that or you can have other kind of categorizations, and then it could become a mental illness if it's because we're not perfect machines. we're actually very unperfect machines because we have so many instincts, so much can go wrong. As you look at a line, you can, yeah. Like post-traumatic stress syndrome, they say that it can be recalibrated so much that it remains there for the rest of your life. So again, our brain is made to solve some problem, perceive some things, but it can still go wrong. And we could remain unaware of our emotional states. Again, we could remain unaware of everything, right? Unless we have mechanisms in our brain to understand the instincts that solve problems and think and learn, then we cannot see it and we cannot perceive it. So that's we only have the mechanisms that we need to solve the problems at hand. We don't have anything more than that. So we don't need mechanisms to understand all mechanisms in our brain. That's not needed. Evolution didn't create that, right? So of course we won't understand everything in our brain. Oh, this is very interesting. Again, jealousy is needed, right? Because you need to, if you didn't have jealousy, then you would just let your mate mate with whoever she or he wanted, right? So you wouldn't even know if the offspring was yours or not yours. That's a huge disadvantage, evolutionary. So of course jealousy is a bit good this way, but if you have morbid jealousy, that could be a bad thing, because you're hallucinating about the affairs that your mate can have, right? And you need this hallucination. You need to think, okay, maybe there's an affair going on. So you can stop it, and you can make sure that your mate knows that you're stopping this kind of behavior and will notice it if it happens. But too much of it can be a disadvantage for you. Again, they also say here, for example, we need to look at the hunter-gatherers. We don't only need to look at modern society. So for example, if there was usually a fight going on, if you felt jealousy and then noticed the sexual infidelity, then of course we need to study jealousy in this kind of light, with violence in it, and look at how will it, for example, if you feel jealousy right now, will you also feel become more violent, and will you also start to protect yourself or stuff like that? We need to look into these kind of things, because jealousy is not developed in the modern world. Memory is activated to reanalyze the past. Confident assessment of the past are transformed into doubts. The general estimate of the reliability and trustworthiness of the opposite sex may decline. And again, we can become violent and punish our mate to make sure that this behavior does not happen again. Okay, where's the rest of it? I remember something, maybe it's here. And you also remember behavior, right? So remember good behavior towards you and negative behavior towards you. Oh yeah, here it is recalibrating emotional programs, programs such as guilt, grief, depression, shame, gratitude. It's yeah, carry out such compensations, but it's recalibrating compensations. So if you do something, for example, if you feel a lot of jealousy and you hit your mate, I'm not saying you should do that. I'm just saying it can happen in some species and probably human beings too, right? So let's say someone hits their mate, so they can have recalibrated emotional programs such as guilt or grief or shame even, because then they will recalibrate their structures and emotional structures and thought patterns and yeah, it's hard to explain for me, but they they will feel this shame, and then they will recalibrate their perception of the world, but they will also illustrate to other individuals that they have recalibrated their perception of the world, right? So you adapt this way. So even though these emotions and programs are negative, for example, grief and guilt, we can still, they're still super useful to recalibrate our mental states and our perception of the world. You attack someone, you hit him, and then you can recalibrate your mental states and then become like learn from it, right? Apologize to yourself, apologize to other people, and then you have another perception of, okay, how should I react next time? Guilt functions as an emotion mode specialized for recalibrating of regulatory variables that control trade-offs in welfare between self and others. So again, you can take too much from a pal. Let's see, your band, that's hunter-gatherer bands, has collected a lot of food, and you take too much of it, you can feel guilt, right? So you need this adaptability, because if you don't adapt, if you always take too much, then the only option is to throw you out or kill you. But if you can adapt, if you can have these other kind of emotions that make you more adaptable, then you're better adapted to living in that group. Oh, we have nearly finished. Yeah, there was oh yeah. Accordingly, we think that over the next 3 or 4 decades, a large-scale correlation goal by the scientific community, it may be possible to turn human nature from a vague idea into a set of precise, high-resolution models of evolved computational architecture, models that can be cashed out genetically, at the cellular level, developmentally, physiologically, and neurally. It will be a fundamental advance for our species to have a true natural science of humanity. They are using evolutionary psychology is again using all these kind of different scientific studies. We study all kind of different stuff. We do brain scannings. We cut up people to look into brain. We study groups. We study individuals. We study laboratory settings. We study them in natural environment. We study hunter-gatherers when could they do not exist anymore, but 60 years ago. We study different kind of cultures. Yeah, perception, different ages too, and object perception. So we can use all these kind of studies, and mathematics. A lot of mathematics go into evolutionary psychology. Yeah, it's a huge subject. So we use more and more of this, and hopefully somewhere in the future we can have chapters not divided by arbitrary stuff, but divided like we divide all chapters in studying other kind of animals. So we need an understanding of human beings that proposes that we are animals. We are in the animal kingdom, and we do have some extra mechanisms and some very, very peculiar and advanced mechanisms. But we also have all these instincts that a lot of other animals have. Probably have most of the instincts chimpanzees have, right? And they probably have 100,000 instincts. Then we have even more instincts. For example, consciousness could be, what is that? Is that just one thing? Maybe not. Maybe it's like 100 different instincts doing their own thing, creating an image in our brain to perceive the world a certain way, to see certain stuff. Because if we don't have instincts for perceiving the world and perceiving ourselves, perceiving our brain, perceiving other people, then we don't have the option to do that. So we could not do it if we didn't have the instincts for that. So yeah, that's why you cannot see everything you do, and you cannot understand everything you do. And the stuff you see and understand, that's the stuff you are evolved to see and understand. So I think that's more than enough for this. And I will see if I can make a short introduction. But I think for you this is great, because if you have a very, very hard time understanding this chapter, you can probably watch this video and get a more clear understanding of it. I'm still not an expert on this field and area, but maybe I said some interesting things